How's it going? It's Dr. Schulman, and we're pushing through geometry. We're doing 6C right now, which is a lot of stuff about naming, definitions, vocabulary. I added similarity to it and some segments, just to like beef it up a little bit since we did so much naming already. Um, I'm going to share my screen. I moved the note page to a new one, so hopefully it won't be lagging, which will be a lot easier for while I'm writing and talking. So that's what I'm going to try this time. I'm going to share my screen. So we're here. So I was originally just going to have them all together. I did the last one, but it keeps lagging so much. I just opened a new one. So here's 6C, and I might make a different one for these one, two, three, four other first set of geometry videos. This is the set we're doing for 6C. You can see right here, no strategies for understanding definitions. I showed you a bunch of stuff for definitions, but let's learn some stuff, right? This one is not that long, so hopefully you find it interesting and you learn a lot. As usual, just feel free to reach out as we go through it, and hopefully I can help it make sense. So here we go. I'm gonna do a little basic stuff for you right here. So for notation, this is a segment. Yeah, oh yeah, so much better. Okay, cool. So I just got to make new ones every time. There's array. A segment stops. Both sides. This is array and this is a line. A line is actually undefined because you can't measure it. A segment you can measure, so this is undefined. And this one we can define, even though it goes in one direction, we have a point that starts with and the direction it goes. So we can define array, and the segment we can definitely define and measure. So here we go in two different ways. So the symbol is one of these. See, look, ray, line, but we want the segment. So we can go TL or we can go LT. Doesn't matter the way. Ta-da! Let's do another one just for fun. Here's array. So the symbol. Here we go. So we could either name it from UI, but U always has to be first because that's the endpoint. So we can call it UI or we can call it UF. You can't go the other way. You always have to start at the endpoint. Let's do one more. Okay. So if we want to name this figure, it's still a segment, it's not a line, but you can't stop here. We want the whole figure, it's either FI or IF. Sorry. Ta-da. And let's do one more. All right, here's a line. So this one has the little arrows on it. So it could either be LN or NL. Remember, this is one dimension. We cannot measure it. You can't put a ruler up because it goes in both directions. So this is undefined term. What are the three undefined terms of geometry? Point, line, and plane. These are the three undefined geometry terms. Three undefined terms because you can't really measure them. You can't measure point. There's no distance to it. So that's why they're called undefined. All right, let's name some angles. Name the marked angle. So we can go URS. We did a lot of this before. And we go SRU. The vertex always has to be in the middle, this endpoint where the two rays meet. Can't go USR because that would change it up. And we'll do one more. This could be SUT or TUS. Sorry about that. Awesome. All right. Let's name a plane. So we need 3 points to name a plane. So we can go XTS. We just need 3 points on the plane. Ta-da. Doesn't matter how you name it as long as you have 3 of the points because you need 3 points to name a plane. Now let's do one more. This is the plane we're looking at. So it's IEH. Notice that there's no symbols to it. All right, well, that was the first 3 points, lines, planes, rays, real common stuff. Hopefully that was useful. All right, let's do some measuring. This stuff I keep struggling with, so just because my eyes are really bad. So let's rotate the protractor using the central blue dot. I'm assuming we got to name this one. So let's figure out angle N. We know it's an acute angle, which is good. Oh, well, I gotta reload the page. It's not being my friend at all. So let's just go to new problem and see what happens. That's okay. Doesn't matter which one they give us. So here's M. I just have to slide this around so I can measure it. So I need one over here. That's here where it starts. And it looks like we are at 82 degrees. 82 degrees. So really practice measuring, helping your student. And this means measure of angle LMN is 82 degrees. Ta-da. Here we go. Beautiful. All right, let's do another one. All right, so now we get to measure a pair of angles. So move the, okay, so we have given QRS, measure QRT. So this makes 180. So we're going to do a little bit of both. So let's start with just one of them. If we go here, we should be able to see both of them. So SRT is, sorry, my blindness, 95, 96, 97. SRT is 97. And together they make a straight line, which is 180, which is called a straight angle. So 180 minus 97 should be 83 degrees. Should be. Ta-da! We got it. They did it the other way, but that's quite all right. All right, let's investigate some vertical angles. Okay, so move the yellow dots to make segments that intersect in such that J and L is an acute angle less than 45 degrees. So JLN is an acute angle less than 45 degrees. I'm going there. That looks nice and small. Move the line so the intersect point is not close to, oh, okay, so they want me to move this back, which is okay. I'll do whatever they want. And we want it less than 45. So here we go. Hopefully that's enough for them. All right, cool. So we want NLN. So all I got to do is drop this down and not be so blind, right? We are at 15, 16.5, 17, 15, 16, 17, 18, 19. Yes, we're at 17 degrees. JLN is 17 degrees. JNL is 17 degrees. And all we have to do is take 180 and minus 17 degrees. And so that means JNM, I'm assuming that's M over there, is 163. The other tiny one, which is KNM, is 17. This is one. I know we did this one before, but you should really practice being more spatially aware. That's kind of the whole point of learning geometry, is learning space. Ta-da! There's mine. Perfect. There's just a lot nicer. All right, so here we go. If we have 63 degrees on one side and this is 90, all we have to do is just do a little subtraction here, nothing crazy. So I know the whole thing is 90. I have 63 degrees on one side, so 90 minus 63. It's going to be 27 degrees is A. I know we did some of these before, but it'll be good to practice. Let's do one that's a little bit harder. Okay, crazy. So we got to find the rest of them. So we have a cross, right? If this is 115, this is 115. What is 180 minus 115? 5. So these two are 65s. And if I have 70, that makes this 110, and that's 70. So H is 65. G is 115 because they're vertical angles, they match. M is 110 and K is 70. Look at us go. Perfect. Notice that they make the 180. Notice these are vertical angles, so they're matching. And let's do an algebraic one. So we know it's got to equal 90. So 7x minus 2 plus 57 equals 90. Well, these are like terms, they come together. That's 7x plus 55 equals 90. We minus the 55 to both sides. Cancel. Sorry, that's 80. And 10 more make 90, so that's 5. So that's 35 equals 7x. We divide by 7, and we know that x is going to be 5 degrees. Sometimes they ask you for the whole angle, but they just want x, so that's 5 degrees. All right, let's keep it going. Here's identifying angles from 3 points. So identify FGH. So we want FGH. So it's going to be this one. There it is. FGH. All of that. FGH. We did it before, so I'm only going to do one of them. All right, so here we go, some terminology. So 106 degrees, 106 is T, Y, W. So that's 4. T, Y, W, that's 106. And if they want V, Y, U, T, Y, W, oh, they're vertical angles, so they're a match. So this one's also 106 degrees. Perfect. They wanted Y, it'd be a 74. Here's with an equation. So they say they're complementary. So let's do a supplementary. We keep doing complementary. Give me a supplementary. Here we go. Here's supplementary. So they make a 180. So that means one is 2x plus 21. One is 3x plus 24. They're not equal. Otherwise, they would say that they are congruent is equal. So remember, congruent means equal in size. That's the equal sign. That's equal in shape. Supplementary just means we add them up. We set them equal to 180 because it makes a half circle. That's 5x plus 45 equals 180. We subtract 45 from both sides. So I have 135 equals 5x. We divide by 5. 5 can't go into 1. 5 can go into 13 how many times? Twice, right? Because 5 times 2 is 10, and 5 goes into 35 7 times. So x is 27. They don't want x, they want angle 1. So this means it's 2 times 27. So that's what angle is. So 2 times 27 plus 21. Always put parentheses here, because otherwise you might mess things up, like with negatives and fractions. So if you're substituting, you should always have parentheses. So that's 1454 plus 21, 5. It's an acute angle. So I have it drawn backwards. So this one's 75, the other one's 105. And we got it. Ta-da. There's all the maths, the plugging in, and the answer. All right, so let's do some segments. So here we go. We got some segments on a number line. Look at the diagram and evaluate which of the statements is false. So these are just line segments. They don't have the lines over the top, which I don't like. So these should all have this on top to signify they are line segments. That's okay. Which are true? So is TU is 1, 2, 3. So TU is 3. RS is 1. Is 3 bigger than 1? Of course. We got it. Is RS equal to ST? No, those aren't the same size. Is SU less than RU? SU? That is true. Oh, they want which one's false. Oh, cool. So it's this one. RS is not equal to ST. Good thing I double checked it. And there's all of them. So these are just segments on a number line. Let's do some segment addition or subtraction. So here's our segment. XY is 9, WX is 3. So you should always draw it, right? WY are the endpoints because that's what's there, and we have an X somewhere in the middle. So we know XY is 9, and we know WX is 3. So to put them together, we're going to end up with 12. Just simple addition. All right, so let's do one that's algebraic with a number line. Okay, so now we still have EG. They're the segments, so those are the points on the side. Have somewhere in the middle. So EF is 5x. EG, so the whole thing is 3x plus 9, and FG is x. Okay, so we have to determine the numerical length. So we need a length here. All right, so we have to find out what x is. Good thing there's a number, right? There's one number here, so we can solve it. I thought they were all letters for a second. So basically, we just know fx, this guy, plus fg, sorry, I have two of them, plus x equals 3x plus 9. That's all we know. 3x plus 9. So 5x plus x is 6x equals 3x plus 9. We divide subtract 3x to both sides. We're left with 3x equals 9. Then all I'm going to do is divide both sides by 3. I have x equals 3, but we want EF. So which one is EF? EF is this one. So this means we have 15, 3, and we can double check. 15 plus 9. 9 plus 9 is 18. Yeah, it works. So they all work. So that's all the pieces. A little segment addition. Ta-da! Perfect. Oh, and they gave us the other one too, 18. I like it. All right, so let's break this into a ratio. So now we have the points N, O, and P. They all lie on the same segment. So we have N, O, P, and Q. They're all on the same line segment. Sorry, it's a little curvy. Such that the ratio of NO is 4, OP is 5, PQ is 1. So they're in a ratio, right? But we just know there's something being multiplied by them. That's why I'm going to put little x's here. Because we don't know if it's 4. It could be 4 times a half. It could be 4 times 3. And we just know the whole, they give us the whole thing. That's nice. It'd be harder if they gave us a little piece, but they give us the whole thing, which is 20. So it's just 4x plus 5x plus x equals 20. 4 plus 5 plus 1 is 10. We divide them by 10, and we are left with x is 2. So I know PQ is 2. This is 10. And this is 8. Now what happens when we add all three? 8 plus 10 plus 2, it does equal 20, so we did it right. They want which one? They want N to P. 10 plus 8 is 18. We did it. Ta-da! Those are the steps. Those are all the little pieces. Then we put those together to get 18. It's a good question. Now let's do some angle addition and subtraction. So we know OPQ is 86. And we are using OPR, so we just have to subtract here. 86 minus 54. We got 32 degrees. Nothing crazy. Ta-da! All right, let's see what else we got. All right, now we got to make some parallel lines. Oh, this was the hard one. Oh, I remember this one. Okay, so we got to somehow make these lines parallel. So I remember the first thing I did was I tried to make them similar, and then I just grabbed this thing. I have to figure out what this is. Okay, so I put you on the line. Oh, no. All right, well, I gotta reload it. I gotta put you here. How big is B? It's an obtuse angle. B is 154 degrees. So I got to make this one be 154 degrees as well. Right? Isn't that what they want me to do? Drag this. So AC, and DF are parallel. Well, assuming they want me to do it like this. Yeah. All right, let's see how close I was. So this is 150. Was it 3 or 4? 154. Did I do it perfectly? We're about to find out. 154. Let's see what we got. That's 140. I need 154. Oh, I'm on the wrong one. That's why. All right, I can barely see what's happening. I'm just going to go to new problem. All right, let's try this again. Third time's a charm. All right, so what do we got here? Go to the one end. Let's see what we're at. We are at 71 to 73. So this one's got to be 73 degrees. It actually looks pretty close. See if you are, in fact, 73 degrees. You are too big. One more degree. Cool. Now they're both 73 degrees. I did it. ABG is 73. DEB is 73. Crazy stuff, right? Measurements. Beautiful. All right, we got to find these angles. These are called what? You got to remember the names. They alternate. These are alternating exterior angles. That's the whole point of these. Can we remember the name? So 43, 43. They were on the same side, they'd be called consecutive. So if it was X and Y, these X and Y are consecutive interiors. And we can get them all. 43, 137, 137, 43, and then you can just drop them down. 43. These are called corresponding, alternating interior angles. If it was up top here, that'd be corresponding. I know there's a lot of words. All right, so let's do another one. These are, I drop it here, it's 122. I drop it here, it's 122. So it makes a straight line. This one, there's no name because, oh, if we have both of these together, these are consecutive exterior. So it's 180 minus 122. And if you want, don't be afraid to let the calculator be your friends. Ta-da, 58 degrees. Boom. All right, let's do another one. These are consecutive again, so this is going to require us to set equal to 180. So we have x plus 13 equals 8. Oh, that was if it was one up. That falls here, so it makes a half circle or a straight line. I've taught this lesson too many times. 8x plus 5, so we have 9x plus 18 equals 180. We minus the 18 on both sides. If you get confused, let a calculator be your guide, but you should always know how to subtract. We have 9x equals 162. How do I know 9 goes in? 1 plus 6 plus 2 is 9. So it's going to work out perfectly. When I divide by 9, it is 18. X is 18. Boom, boom, boom. They wanted the angle. What is 18 plus 13? That's one. That's all the acutes are 31, 31, 31, 31, 31. And the other ones are 149, 149. All right, let's keep it going. So here's some transversal that are level 2. These are called vertical angles. Anytime they crisscross like this, the naming is vertical. That's why I have all these here. It's just to help you practice all these names. So as long as they crisscross, you can think they make a little bow tie. I know I'm not a great artist. All we're going to do is solve. Always leave your X on the left. I know this isn't the algebra part, but I promise you, anytime you have an inequality, it'll help you out a ton. Plus 17 to both sides. 11 plus 17 is what? 28. We divide both sides by 2. We're left with X equals 14. And that's where we have it. We have 14. Okay, so we're doing some similar figures. I'm sure you've seen this before. I just want to throw these into geometry again, just because we really need them. Okay, so we have a trapezoid. Okay, so don't be afraid of it. Here's a trapezoid. It is MN. We always have to go in order. OP. It's dilated by a scale factor of 2. So whatever we did, we multiplied it by 2. That's what dilation means. Okay, that's why it's all about learning these terms. So here's M prime, N prime, O prime, P prime. So the primes mean, they're called primes. It means the new image, twice as big. We times it by 2. So side NO measured 29. So what is the new side measure? Well, we just have to double it. It's 58. All right, let's do this, but harder. Let's step up the difficulty. Okay, so now we have the picture. We have it now. So there's tons of ways we can do this. I do a little big. I'll show you a few ways to do this. And then we have, I'm assuming we need UT. Yep, that's our X, and that's our 10.6. So you can go little, big. Then we can do right and bottom. Doesn't matter how you set one of these up, but the students seem to always grasp it better when I have a little model, something they can plug it into. So the right little is 3, the right bottom, sorry, the little bottom is 2, the big right is X, and then this is 10.6. A lot of times, as long as they're facing the same way, I'll just show my students to do that. We have the same thing, okay? Those are 2 ways we can do it. 3 over 2 equals X over 10 minus 10.6. Here's the thorax, the antennae, butterfly rhymes with cross multiply. So we're left with 2X, oops, sorry, 2X equals 3 times 10.6. To get X alone, we just divide it by 2. I know there's a much faster way. I see the scale factor, but that's okay. 15.9 is the answer. Notice that they're not always drawn to scale. These are, they look like they're acute scaling triangles. Ta-da! So they found the K. They found the scale factor first. All right, so I did the proportion last time. Oh, sorry, I guess I hit it too fast. Are they matched up? Yeah, so we have to find KJ, I'm assuming, or JK. So we can put an X here. So we'll just do this one kind of fast because it looks like the same one. 3 over 7.9. Notice that it's quadrilateral because we can't tell if these are parallel for it to be a trapezoid. You'll see these problems like 100 times. 7.9x equals 3 times 30, which is 90. And we just divide it by 7.9. And we got to round to the nearest tenth, so that's 11.4. All right. So let's step it up. Level 2. I'm assuming they're going to get hard at some point. Okay, so this one's hard because you already have to rotate. Oh, it rotated for us? That's cool. All right, so it already showed us the flip. So other terms, rotation, reflection. Time for me to add something. I knew there'd be a time. So I'm going to go to my drive and I will teach you something else. And here we go. Transformations in action. On this one, I'll just open my other drive. Here we go. So here's a great set of slides. Super fun. I'm going to show you all the transformations before we do this one, even though it's not needed right now. And here, let me share this in yours. Sorry, that was just an email for a student. Good thing it blacked out. We're here. All right, so let's put this module. Let's go into this one. We are on C. I always want to teach you a little bit more than just the stuff here every time we do it. So here's transformations. And I'll go through these slides kind of fast. Transformation definitions. There we go. All right, so here we go. Here are the slides, but I'm going to write on it. But notice there's like the transformers. Obviously, before everybody's time who was taking this course, but there were movies. They weren't the best, but they existed. All right, so I'm downloading this as a PDF. Sorry you won't get to see all the cool spinning and flipping and sliding and all the aliens and all this cool stuff. That's okay. The notation's really nice. So is this it? Oh no, that's the everything. I thought I downloaded it. Here we go. All right. So here, let me teach you some stuff. So there's this word, some definition. It's called isometry, okay? So isometries are equal in size and shape, okay? Boom. Pre-image is before the transformation, before it happens. This is called a stretch. And this is dilation. So the dilation you might think can be just bigger, but it can be bigger or smaller. Notice that the stretch is the only one that changes shape because it is not asymmetric. And notice the symbol of congruence. It has equal in size and shape. All right, so which one is the same? This guy? Nope. Yep. Nope. 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 Okay. Which one's not a transformation? This one. So we got our girl Jane. She claims that circles are always isometric because the shape never changes. She is wrong. Different size. We can see here. What is that? 10. This would be 30. All right, so in your own words, what are they? So a rotation is a spin, and this is what it looks like. R, this little O, I'll do the notation after. Translation is a slide, you're sliding. A stretch is kind of like you're pulling it. Dilation is a shrink or grow, and a reflection is a flip. All right, so this is a translation. Notice this is the one that's 6y. This is the first image, the pre-image. And these have primes, so you know they're the after, okay? They're after. Now, this T stands for translation. The 6 means X. It means 6 right. If it was a minus, it'd be 6 left. The Y just means it stays. The Y stays. If it was -2 here, it'd go down. So the X always goes left and right, and this one always goes up and down. Here's your reflection. This is always what you're reflecting over. So this is our pre-image. That's our image. Oh wait, it's the other way around because the arrows are going this way. So there's your pre, there's your image, and we're reflecting it over the y-axis. Or it could have said x equals 0. They're the same thing. It means we're reflecting over this line. You can always count 1, 2, 3, 4, 1, 2, 3, 4, and they match. All right, here's your rotation. All right, so this means from the origin. So it could also have a little OO if they want. And this is -90. Geometry always goes counterclockwise. So it goes 1, 2, 3, 4. So -90 means which way? Clockwise. Okay. And here's your dilation. So this is a 2. There's our first image, and it is. So that's your center of dilation. So, because you can grow from any point. You can grow from here, and then it like looks like it's getting all crazy in 3D. All right. Here's stretch. I didn't put it on here, the notation, because it's a little beyond. So let's see what happens. All right, so this one is not isometric. We got a stretch. Isometric, it looks the same. It looks like it's rotated. Notice that we just do words. We get a little bit more challenging with the shapes, and then we get harder. This is isometric, it's a reflection. This is not the same size, it's a dilation. This is isometric, it's just slid, so translation. And this is not isometric, it's another dilation. You can see the same thing with triangles if you want, but I'll skip through these because they look the same. All right, so this is what a problem could look like. So if we have xy and it goes -xy. So if I have the point, this is just a slide. Or a translation. Sorry, I should start at the first one. This is what a problem would look like. So these are your points. 1, -4. So if this went down 5, oh, sorry, to the left 5, it's going to be -4, and then it's going to go up 3, -1. So, or we could even move it. Ready? -1, 2, 3, 4, 5. And then we got to go up 3. 1, 2, 3. This is A prime. B, we can just count them if we want, or we can subtract. It's -3. And this one's going to be +2. So -1, 2, 3, +1, 2. Here's your B prime. And C is going to be 1, -1. 1, -1. Here is your 1, -1, not +1. Sorry, I could see it was in the wrong place. So here it is. Does it look like the same size and shape? Yes, it's a translation. So it'd be T -5, 3. I'll do one more, but you definitely want to try these. So the x becomes negative, the y stayed the same. So 1 is -1, 2, you just flip the signs. 2 is -2, C6 is -6, and they stay the same. So -4, -1, -4. So ready? -1, -4. Looks like a flip to me. -6, 1, 2, 3, 4, 5, 6, -4. And the B is -2, -1. Here's B prime. Looks like the same size and shape. Yes. It's a reflection. So this would be a little r. So it look like this r over the y-axis. So here's some really good problems to try. I think they'd be really useful to see what happens. This is a dilation. It's just going to be half the size. I'll show you one hard dilation. So this one's using the origin, but let's use a different point. Let's dilate from something crazy. Yeah, these are tough. These are all tough. All right. So which one should we do? Dilation of 3, dilation of a half. Okay, cool. So the first thing you do is you plot your center. So our new center, the origin was here, but now our origin's at 1, 2, 3, 1, 2. Here's our new center. So this is our new center, okay? So this is how you can dilate from a point. So this thing is going to be half the size, right? But it's going to be from here. So we have to count the new points. I'll call it A, B, and C. So from my new one, A is -1, 1, 2, 3, 4. A is -1, 4. What is B? B is -1, 2, 3, 4, 5. 1, 2, 3, 4, 5. B is -5, +5. And C is 1, 2, 3, 4, 5, 6, 7. C is -7, 1, 2, +2. Now, all the old points don't matter, right? So we plot the center, that's 1. We counted our points. We're going to apply our dilation, which means we basically multiply by a half. Then we have to count the new distance from the center, and record our new points. All right, so let's do it. So we have to multiply this by 1/2. So this is going to be a what? A prime is going to be a -0.52. So a half, 1, 2. Here's A prime. All right, so times it by a half. B prime is going to be -2.5, 2.5. -1, -2.5, 1, 2.5. Here's B prime. And where's C prime? Well, what is half of 7? C prime is -3.5. 1, 2. Yeah. Sorry, 1, 2, 3.5. And then it's 1. So here's C prime. 3.5, 1. So here's our new triangle. Now, I always tell my students to connect the dots using a ruler. It'll be hard here, but basically it should always look like a 3-dimensional image hitting the center of dilation. See? It's like it's growing. Then you just record the points. So this one, you finally go back to the center. So this is a half, a half. So B prime is 1/2, 1/2. A prime is 1, 2, 3.5, 0. 3.50. And what is C prime? -0.5, -1. That's how you do a dilation. You can practice some of them if you want. There's great lessons where you have students create their own pixel image and then have them grow it, but these are all cool. There's some more to try for dilation. Lots of them. All right, let's get back into it. So I hope that wasn't too much of a rebrief, but I'm always going to try to teach you stuff. So basically, we just did what? We rotated this thing. So this whole thing flipped around. So basically, we have to know what piece goes where. So what matches to what, right? So I believe the 31 matches to the what? 14. That's why these are so hard to do. So we have 31 to 14, and I believe we have 49 to X. So that means that KN has to match to RO. It doesn't look like it, but that's how it happens. So this is 31 times X, and this is 14 times 49, and we divide both by 31. 14 times 49 divided by 31. So the nearest tenth is 22.1. Don't be afraid to give your students transparent paper, tracing paper to help them with this because it can be tough. I did a different way. You can set up any way you want. They did one over the other, but as long as you stay consistent, you see how mine's different from theirs? I was consistent. We got the same answer. All right. Oh, level 3. Level 3 doesn't flip it for us. We have to flip it. So I'm just gonna, to me, this is standing on its side, and now it is. So here's the little guy. Oh my God, I can't draw to save my life. Sorry. So we have boom, boom, boom. Yeah, that was right. We have the big one. So if this was on top, now it's on the side. So there's 14, there's 9, here's X, here's 41. See, we have to flip it ourselves. And since we've already done a few of these, this is how I do it. 14 over 9 equals X over 41. We have 9X equals 41 times 14. And we just divide it by 9. So 41 times 14 divided by 9 will give us X. Round to the nearest 10th, so the 63.8. Ta-da! Oh, wow. All that fancy stuff, right? That's the hardest part, visualizing the spin. So don't be afraid to give your students clear paper and have them, move it. Sorry, I just thought of something. Another thing that we could add here. Let me just find my pens. All right. If JH, okay, so I got to do some drawing. We have JHI, and the top one has to be M because it has the same what angle, right? So these are similar. This means they're the same shape, they're just different size. H matches to K, and T, H matches to K. There is no T. Oh, that's an I. I matches to L. There we go. All right, so here we go. JH is 26. HI is 20. JI is 24. And ML is 37.2. They want the perimeter of this one, so we need both of them. So we could do the scale factor way. Well, there's a bunch of things we can do, right? We could do 24 equals 37 times K. And we can divide it. So what's 24 divided by 30? This is finding the scale factor first. Because we have to do it twice, it might be easier just to get this. So we know it's 0.64 something. I guess I could do it the other way. 37 over 24, maybe it'll be a prettier number for the scale factor. Nope, doesn't matter. Gotta love it. 24 divided by 37. So we know it's 0.6. Oh, I actually do have to go the other way. 24 divided by 37 is 0.648. There's your scale factor. So basically, no, I had it right the second time. Oh my God. 37. This is why I never do it this way, because sometimes it's just confusing. So we know it's 1.54. 1.54. So all I have to do is take each of these and multiply them by 1.54. So 26 times 1.54, that's the scale factor. That's how much bigger it is. 40.04. And then this one is, and this is 20 times 1.54. So the bottom is 30.8. So then we just add them together. 30.8 plus 37.2 plus 40.04. These are what? These are called scaling. These are all scaling because the sides aren't equal and they're acute. That's it. 108.04, round to the nearest tenth. So it's just 108. Whoa. Give me a break. Give me a break. So I got 40.04 and it should have been 40.3. So that's the only one I missed. So 26 times 1.54 is 40.04. I guess because I didn't use the rest of it. I don't know. We could do a new problem if we want. Find the perimeter of UVW, UVW. I'm going to try the scale factor one more time. So 40, it's between 44 and 83. So it's 16. So 40 divided by 16 is the scale factor, which is 2.5. It's 2.5 times bigger. So all I have to do is take this one, because this matches here between 44 and 53. So I just have to do 20 times 2.5. And so I know the bottom is 50. So it's 50 plus 40 plus 35. 125. Guess I just got tripped up in all the decimals. Ta-da! So the scale factor way was way faster than doing this. Well, I had to do it twice the other time. I think that's why it threw me off. All right, so we got to see what matches. Figure 1 are similar, which means they're the same shape. They are just what? Reflected and dilated. That's called a composite. So this is another symbol. When you do multiple moves, this always happens first. This happens second. So it could be like a translation of X7 and a rotation from the origin 270 degrees. This would happen first and then it's spun. So this was probably, I don't know what happened first, but it was reflected and then it was dilated. And then it was translated, so it's moved a bunch. So which matches to Z? F. What matches to PO? PO is KH. Line segment KH. All right. Whoa! Isn't that cool? All right. Use the drop down to remember if they're congruent, similar, or neither. This does not look like the same shape. ST is not the same as AB. So this is not congruent because rigid motions cannot be used to match them. And it is also is not similar because dilations cannot match them. No matter what I do, this thing will never match up to this one. These are congruent and similar. I believe so. Yes. Yes. Is, can, is. I thought it was going to be can. The scale factor is 1 because I think they're the same. I think they're the exact same size. I'm going with it. Nice. They are exactly the same size. Whoa! Whoa! So there's the composite. So this would look like reflection over the x-axis. So that's the first move. So it's reflection. I know it looks a little backwards, but that's the first move. And then the second move is a translation. 1, 2, 3, 4, 5, 6, 7. What did we got? We got 1, 2, 3, 4, 5. 5. And y stays the same. Cool. All right, let's see what else we got. A little bit of proving. These triangles, so we have 39. Yeah, they are because of angle. So, I'll do a few of these. So we have side, 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 that's congruent. We have side, angle, side. We have angle, side, angle. So these are all congruents. And then we have angle, angle, which is just similar. And I think we also have angle, angle, side. Yeah. So all of these are congruent. Let's do another one. This is side, side, are they all by the same one? Is it times 5? Yeah, I think they are. They are similar. Because of sides, 3 sides congruent. No. The sides are proportionate. It is 5. They're all 5 times bigger. Very cool. All right, let's do one more. All right, so this is angle, side angle. This is angle. Oh, it's not. What's 88 plus 53? 88 plus 53 minus 180. 39. And this is 38, so they are not similar. This missing angle could have been 38, but it was 39. So the angles didn't match up. See, they're not equal. Let's do one more of these. 18, 20. All right, let's try this. Is 18 over 20 equal to 72 over 80? This is times 4. So this is another way. If the scale factors match, what is 18 times 4? It is. So this is side angle side. So they are similar because of side angle side. 2 sides are proportionate and they included angles. All right, we should do one more. Because all you need is 2 angles, and that means the third angle has to match, which means they are the exact same shape. Move out of my way. All right, and here we go. We got a couple more. Oh, I saw this one on one of the practice exams for the licensure. So in the diagram, OP is parallel, LN is 9, OP is 4. Find the length of ON. LM is the same length as ON. LM is the same length as ON. And LN is 9 and OP is... Okay, wow. What a tricky problem. I'll show you. So this is it. So these guys are parallel. I'm just gonna make one here and one here. I just ripped them apart. You know, here's the little one, NOP, and here's the big one, LNM. Okay, so we know that LN is 9. This whole mess is 9, and if that is 9, sorry, and if the length of LM is the same as ON. So LM is the same as ON. So these little hash marks means they're congruent. Okay. And we know that one angle is equal to the other angle, which is fine. And we know that OP is 4. And we want this one, ON. So we know this is X, but we know this is X. So this is what I think we have to do. I think it's going to be 9 over X is equal to X over 4, because these look like the exact same shape. We know that they're congruent because of this. So I believe it's 9 over X equals X over 4. X times X, that's X squared, and 9 times 4 is 36. We take the square root. X is plus or minus 6. Okay, so it's positive 6 or negative 6, but because it's a distance, we reject the minus, so it's just 6. Wild. Wild. Wow. Yeah, I got the same thing. Really cool. Really cool problem. Yeah, this was on one of the practice exams. All right, so we know that G matches to J, so it got rotated. So HI is KL. And GH is JK. You just always want to go in the same order. Ta-da, it got all spun around. All right, so here we go. Here's a word problem. This one looks fun. So a pole 7 feet tall. This is support wire. Got our boy Tariq. All right, so we just got to find what's the length of what? Find the length of the guy wire. We have to find this length. And the diagram is not drawn to scale. We don't have to. A pole is 7 feet tall, supporting to support a guy wire for a tower. Okay, so we just have to find this distance. How long is this wire? We can get this piece, and then we can do the. So this is a two-part problem. So I like that this is just a level one, but here we go. So this is 3, that is 7. Then I need the big one. So this is 19, right? So the whole bottom is what? 22. So this is 3 to 22 as 7 is to X. So this is the hardest part, like just being able to figure that out. 7 over 3 equals X over 22. So I have 3X equals, I multiply just 20 and then 2 and then add it together, but don't be afraid to use your calculator if you need it. 154. All we have to do is divide that by 3. It's not going to be pretty. 51 and a third. That's the whole thing. 51 and 1/3. So now we need this one, but we can use Pythagorean theorem because we have a squared plus b squared equals c squared. So we know it's 22 squared plus 51.3333 squared. So we have that. So we know it's a squared plus b squared equals c squared. We know this is 51 and a third squared plus 22 squared equals c squared. So it's 26351111, 2635.1111 equals c squared. The opposite of squaring is a square root. So all we have to do is square root this answer. We want it to the nearest foot, so it's 51 feet. Let's see. What? What did they get? 56? I'm having a hard time with this. We should get the same answer even if we did another way. 19 plus 3 is 22. Sorry. That's 22. So we got the height. It should work no matter which way you do it. Yeah, 51 1/3. Then we can just use Pythagorean theorem. It shows that it's a right angle. So 51 1/3 squared plus 22 squared. Yeah, plus 22 squared. Oh, okay. Well, I typed into the calculator wrong because we just needed the square root of this thing. Yeah, 56. 56. Cool. I just typed into the calculator wrong. 56 is what I got as well. Okay, cool. Well, we're doing a level 2, so we might as well step it up. Oh, because there's no picture here. So we got our boy Jason. He is 1.85 meters. 12 noon, he measures the length of a tree shadow. We got a little tree. It doesn't look like a tree. Cool. So there's our tree. The tree shadow is 39.95. And he stands 35.2 meters from the tree. So the tip of the shadow, so that the tip of his shadow meets the tip of the tree shadow. Okay. Okay, I see what they're doing here. This is wild. So we have a bright sunny day. Look at that happy sun. So you got a kid who's 1.85. His shadow is here. So that the tip of his shadow meets the tip of the tree shadow. No, I think I had it right. The tip of his shadow is here, meets the tip of the tree shadow. Yeah, that's it. Yeah, okay. I thought they were going to be like separated like this, but then the shadow wouldn't work, right? Yeah, that's not what they want. That'd be weird. All right, cool. So find the height of the tree. Well, this shouldn't be too crazy. So if we know the whole thing is 39.95 and this is 35.2, the first step we have to do is subtract 39.95 minus 35.2. So this is how far he is from a shadow, 4.75. So that's it. The whole tree is, so that's x over 39.95. We got the kid, we got his shadow, and we just cross multiply. So it's 4.75 times x equals 1.85 times 39.95, and then we just divide it by 4.75, and we are left with the correct answer. So here we go. 1.85 times 39.95 divided by 4.75. How many meters is this tree? To the nearest hundredth. So that's all right. So we got, this is our answer, 55.5594. So there's our 10th, there's our 100th. We have to look here, right? However, this brings it up. Oh, so it's just, that's where it is? 1.559. So it's just 1.56. I thought we'd have to do something weird. I don't know why. Ta-da! Ooh, look at theirs. Way better tree than I got in my picture. Perfect. Set up the proportion. We divide by the 4.75, 15.56. That's the answer. And here's the last one. So here's the last one we're going to do. Similar triangles with an altitude and hypotenuse. So altitude is just this piece where it makes the right angle. Given the right triangle ABC with an altitude BD, oh, so that makes another right triangle. What is the length of DC? Okay, so because it says it's an altitude, this little triangle is, there's the right angle, it's right here. So there's your X, and there's your 3. That's the hardest part, redrawing that piece. Then I have to flatten this guy out so it looks the same. And then we know there's your right angle. So if we flip this over, we know we have 9 here. Okay, but that's not the one we want. Okay, so this is an altitude. So this is 3, 9. So I know I can have a 3, 9. Okay. Then we also have this one, the biggins. All right, so this is the bottom, which is 9 plus X. And we need to know CD. We need X. We definitely need X, but I feel like I'm missing another side. Oh, because there's also another mini right triangle right here. The tiny one. That's going to be 3X. Okay. We can get this one because it's a right triangle. So this is 81. That's 9. 81 minus 9 is 72. We need the square root of 72, which is 8.485. So 3 over this one is X over 3. That doesn't make any sense. All right, let's see how they broke it down. Oh, they're not going to show me? Oh, yeah, run this animation. Oh, it is just 3. Ah, it is just 3. That's wild. That is so wild. Let's look at one more. Woo! These are crazy. That's 75 X. Here, I'll just walk you through the solution because it's the last one. So let's watch the split. That's the hardest part. These splitting them up is real tough. So don't be afraid to have the students draw it and then cut it, you know? And then once you have it, you can see it's 60 over 15 X. Okay, so that's the way they did it. All right, let's do one more, but show question. All right, let me try to cut this guy. So I have an X, I have a 6, I have a 6. And there's also a right angle here. So let's take one of these here and go 6X. And then can I do this bigger, which is going to be, oh no, it's just side to side. The other side, I can go 6X and 6X. Okay. Is it just, what? X over 6 equals X over 6. I want to look at one more. Oh, because that's where the other one is. Oh my God. Okay, sorry. All right, let's try another one of these. These are always crazy. These always trip me up. So, all right, so we have this one, right? So this is X and 15. And now we have this one, this little one over here, which I believe will be 13 and X. But if I flip this down, I think this is the match. I believe it is going to be 2 and X. I believe that's what's happening. So I believe it is going to be X over 15 equals 2 over X. I think it's going to be X squared equals 30. So it's going to be the square root of 30, which is, if we break this down, I just put the square root of 30. Let's see. I had it right the first time. Wild. Given the right triangle ABC with altitude of BD drawn, if BD is 2 and DC is 1, what is the length of AD? I usually have to trace these things, but I feel like, oh, okay, I see it. I don't know why it took me so long to start visualizing it, because this stuff is tough, right? So we know this is going to be X plus 1. That's this big side, okay? This whole thing is X plus 1. Now this one's just going to be 1 and 2. Because I can just take this and flip it this way. So that's going to put a 2 here and a 1 here. They want the length of AD, so this is the one they want. So if this is 1, this is 2. 1 squared plus 2 squared equals this one. So that's going to be square root of 3. Sorry, no. 1 squared plus 2 squared. So that's 1 plus 4, so it's root 5. So I have this as 1, 2, root 5. And if I flip that over here, X plus 1 is there. But if I can flip this other one around, I should be able to see. There's the 1, 2. And can't this one also be a match if this is 1, 2? 1, 2. 1, 2 and root 5. And this one, if I root 5 matches to X plus 1. Yeah, that's what it should be. But I don't have the base. I'm probably doing this way too convoluted. X plus 1 equals some constant times root 5. All right, this is way too complicated for the math that you need. So let's just look at it. Just for 1, 2 matches to the 2, 1. Huh? Well, I got the 2, 1. I did not get the X. And oh, because it was the other way. All right, I'll try one last one. All right, here's the last one. Okay, so this side is 2x. I'm not giving up. Okay, and then we have the big one. And the big one has x on the bottom. I got it. Why did it take me so long? But guess what? Stuff is hard. Stuff gets complicated. I was literally just staring at it and like twisting in my head. The best thing to do is draw it separately and turn it. But at least I got it right. So it's x over 2 equals 11 over x. we're left with x squared equals 22. It's the square root of 22. I don't know why that was so hard. Oops. But what? Mine looked fine. X over 2 equals 9. How does this X match here? Oh, I did have it right. Because the whole thing is not 11. Because that's 9. The whole thing was 9. I did do it right. Oh, man. Because this whole piece is 9, not just stopping here. All right, cool. So we have X and 7. Then if we flip this one over, where the 7 is, we have there's this one and there's this one. We have to flip it over. So there's 5. And there's X. Root 35. Sorry for the mistakes, but I haven't seen this stuff in a while. I did it. Yes. Sorry. Well, we all make mistakes. I just was trying to mentally flip those in my head, but I got it. I might add some stuff about similarity, rotations and things like that, but I hope this was interesting for you. Again, if you have questions, just reach out and enjoy your day.